All right, welcome everybody to Hands-on Machine Learning and Engineering. Today we're going to talk about experimentation. This is a pretty huge and fascinating topic. There's a ton of material that can be covered, but as always, today we're going to try to make it useful for us, for our practical use case, and for our general problem of having to roll out models and use them in the real world and make sure that they generate actual value. So the way that we're going to do that is we're going to talk about A/B testing, we're going to talk about multi-arm Bandit, and we're going to talk about the general idea of rolling out different models through experimentation. I hope you're excited, so let's get into it. All right, so why do we need experimentation in the first place? Even before looking at this slide, the way that I think about experimentation is that if tomorrow I purchase a new oven and I start cooking some stuff, and I start to wonder whether I'm going to need some kind of glove at some point to pick up the plates from the oven. One thing that I could do directly is I could purchase the glove directly, assuming that the plates are going to be hot when they get out of the oven and that I'm going to need it for sure. So I just go ahead and I purchase one and I live happily for the rest of my life because I never get burned. But the looming question here is always the same. Do I actually need this oven? Do I actually need this glove in the first place? And so one day, what I'm going to have to do if I want to be at peace with myself is I'm going to have to open the oven, touch the plate as it's coming out of the oven, and see if I burn myself. This is exactly the experimentation unit that I need to figure out whether I made a good purchase or not. Even better, I should actually do that before purchasing the glove. If I burn myself taking something out of the oven, I will have an experimental result that basically tells me that plates are pretty hot when they get out of the oven, and I will therefore purchase the glove. So we're not too far off from this idea here when we talk about experimentation frameworks in the context of machine learning engineering. And the reason for it is that the problem setting is pretty much the same. We have, in general, a bunch of different models that we can use to solve a bunch of different problems. And we train these models and we start observing the results that they give us in the lab, basically through the process that we've done so far. But the question remains the same. When I deploy this model in the real world and I start gathering some data that is not from my observational data, it's new data that's generated by having, for instance, new players play against my AI model here and generate new games and new hands. Are the models that I deployed still the best performing models against the people out there, or are there some new versions of the model that would be better and that I should roll out? And that is exactly why we need experimentation. We need to roll out these models, we need to experiment on them, we need to see what kind of performance they have in the real world, and we need to take an action based on what we observe with these results that they generate in the real world. And traditionally, the way that experimentation has always started is by having a traditional A/B testing framework. That's a very powerful framework. It's used not just in machine learning engineering, obviously, it's used in every part of software engineering. For instance, when software engineers release new features, they release like a new UI or a new feature that people can use on a website. Very often, people are going to start to wonder which version of these features are the best. Is it the one that has this color, that has this format, this shape? Or is it this other one? And the way that software engineers are going to think about experimentation and A/B testing in particular is that they're going to get a subset of users observe or use one of the features developed in one way and have another subset of users say the same feature a little bit tweaked on another screen. And whichever user has the best interaction with this feature, for instance, they use the feature the most, they click on it the most, interact with it the most, basically leads us to believe that the feature that they've played with is the best one. So that's traditional A/B testing in the context of software engineering. For us, the way that we think about A/B testing is that we're going to have two models, model number one, model number two, and each of the models is going to be deployed through the game, through the app, so that people can play with it. And that's actually what's already been happening in the past. Whenever I've had an idea for improving the model, I've deployed this model in the actual platform so that I could just play against this model and try to beat it. And essentially, I have collected new data that shows me how this model that was trained on previous data performs in the real world against my current self, let's say. And now that this model has been exposed to the real world, what we observe is average reward. Reward is just a technical term for payout or outcome that we observe. For instance, in software engineering, when you release new features, the reward could be essentially the number of clicks that the subset of users interacting with this feature has generated, or it could be the number of views, or it could be the conversion rate, stuff like that. For us, the reward is just going to be the outcome achieved by this model, the number of points that this model is generating in the real world against players who play against it. And this is exactly what we have here. What we see through our A/B testing setting is that we have two distributions telling us what is the average reward that the model is generating and what is the spread around this reward, or let's say the variance against this reward, so that we can have a little bit of a statistical framework and statistical underpinning of the answer that we're going to provide. The answer being which model is performing better. And if you only observe the reward, then you can only say, hey, based on this sample that I see here, this is the average reward for model 1 is 100 and the average reward for model 2 is 200. Computing as well the variance of the reward is pretty important too, because it's going to allow us to create things like confidence interval, or, well, generally speaking, let's say statistical validation that the reward that we observe is not due to random sampling or random chance occurring within the sample, that it's really what's going on in the real world. And so essentially what we're going to have now through this A/B testing framework is, let's say, two value of the reward for the two models that we have that allows us to compare which one is really working better in the real world. And with a value of 200 for model 2 here, we can conclusively say, by computing the confidence interval around the average reward, that model 2 is the one that's performing better, and that's the one that we should deploy into production. Now, things gets pretty interesting when you move away from this traditional A/B testing framework and you start treating the experimentation framework as a multi-arm bandit or a contextual multi-arm bandit. Why do you want to do that in the first place? Well, traditional A/B testing is a powerful tool, but it's pretty interesting to start to generalize this framework, because if you think about it, you have two models and you observe the reward of each of these models, and then you take an action based on this reward. Well, you can reach the point where instead of you having to do this observation, this action taking, and this kind of stuff, you might want to reach the point where you want to get to a framework that is, let's say, I don't want to use the word automated, but that is a little bit more abstracted from traditional A/B testing. It's a framework that basically leverages 3 steps: a state observation, an action taking, and then a reward generation, that basically encapsulates the idea that you want to evaluate which is your best action, which is your best policy, or in our context, what is the best model that should be used in production because it generates the highest reward. It's the hardest model that you should play against. And so instead of having the traditional A/B testing framework here, what we're going to have is a starting state, just some information on how the two models perform in their starting state, an action of, let's say, which model should be currently used or currently deployed in production so that we gather some data on the model, and then a reward associated from having the model picked and deployed and having basically people play against it in production. Again, the reward here is the average number of points that the model is generating. Maybe I should have mentioned that earlier, but let's say the reward here is the number of points that is generated by the model. And the assumption here for creating this reward is that when people play online, they want to play against a tough opponent, they want to progress, they want to improve. And the way to do that is by having the best opponent in front of you, right? So that's why it's desirable to have a model that generates a higher reward or higher number of points. That basically means that they beat the human players more on average. So the way that the system is going to work is, again, we're going to have the state, the action, and the reward. And then progressively, what the multi-arm bandit is going to do is it's going to start rolling out the model that little by little starts displaying the highest reward. Let's say start conclusively show that they generate higher reward. And here we enter one of the most important concepts in the world of experimentation through multi-arm bandit, and that's the concept of exploitation versus exploration. Because if you think about it, the way that the system is going to work here is that our algorithm, our system here is always going to have to make a decision, a choice between using a model that it believes is currently performing very, very well. This is the exploitation phase of the system, versus trying out new models that emerge or models that have been tuned, which potentially could start displaying a better average reward, but which are not, let's say right now, currently believed to be as strong as the model that's top dog or like the champion. And so that's the exploration phase. The exploitation versus exploration, it's a classical topic in the world of multi-arm bandits, and we're going to see in practice for us what it looks like in terms of a real deployment of the models and a real system that would choose which model is the best in production.